In this week's podcast, I sit down with David Tuhy from Intel. We've known David for a while. He's a good friend of StorageReview, and he runs the Optane SSD business over at Intel and has a number of thoughts about how data is changing and organizations are adapting to change with Optane SSDs to take advantage of that excellent write profile. So we talk about that. We talk a little bit about the future of storage from an Intel perspective, and David gets into one of a couple of use cases that are doing good work with Optane SSDs. So join us in this conversation. On the podcast today, we've got David Tuhy, Vice President and General Manager of the Intel Data Center Optane Storage Division. That's a lot of words. David, thanks for joining us today.
Yes, we call ourselves DoD for short, Data Center Optane Division, just to make it easy.
Wow, okay.
And one of my senior directors is an ex-Navy Academy guy, so we always tell him we named it DoD after him, in honor of him.
Well, there you go. So it's well into almost summertime in your part of the world in Arizona. Last time you and I met was in Texas in November when it was 33 degrees or something atrocious like that. That was miserable weather.
It was unusual for Austin, that's for sure. And it was sure none of us were equipped right for that kind of a cold, so we were all bundled at our little external events.
No, not at all. That was for a Dell event, and we went on the Alita studio that later that night, or maybe it was the next day. I don't remember exactly the timeline. And it was so cold that they were handing out those little hot charcoal hand packs and scarves.
But we got some cool hats, and the Dell event was amazing. I mean, we went to Rodriguez's studio and did a tour of and they use a lot of technology. You know, they're a big buyer of CPUs and SSDs, which I make. So,
yeah, you're good friends, huh? Yeah, we did get good hats. I did my cowboy hat was much delayed, but I have it now, and actually I broke it out about 2 weeks ago outside, and it's a good look.
Yeah. You won't believe it, but because of COVID-19, we're working out of our house, and right now my dog is barking at somebody.
Well, that's the challenge.
I apologize for the background noise, but at least it's not the little kids, but it's the dog. So, yeah,
that's okay. We've been lucky enough, or I have, to be able to go into the office, but it's a different challenge. It adds authenticity. It's okay.
Hang on, I'm just gonna try to quiet her down a second.
Okay.
Lay down. That's what we call working from home, right there. All right.
There you go.
No, I've never heard her make this noise before. She's talking to me. All right. Sorry. Back to you.
All right. So at that Dell event, one of the things I know they were starting to get excited about are not just Optane SSDs for the enterprise, but the dual port drives. So they had announced those support in PowerMax, I think, and now they've got that as part of the new PowerStore that they launched this week. That's kind of neat. What sort of traction are you seeing with that dual ported product for the array business?
Yeah, it's picking up quite a bit. You mentioned the PowerStore was just announced last week, and
Tuesday.
This
week, yeah.
It feels like I lose the time continuum, but and we're really excited about that. That's their mid-range kind of solution. And we have the PowerMax, which is the high end, that's what's amazing about working with the Dell EMC engineers is they control their entire workload. They have complete control of where they place data in very fine granularity. And so they're able to do some things to take advantage of the technology, which will appear unique just because they have super control over how they do everything. And so we're very excited about it. IBM announced in February, Pure Storage announced last fall, and more coming. It's very simple. They as they move forward to all NVMe infrastructure, they're running into new bottlenecks, and Optane is an amazing thing for fixing bottlenecks to scale. And what the end user sees is more performance, better latency, better IOPS. But in the end, what we're doing is we're fixing bottlenecks in different storage architectures because the speed of the CPUs is getting so fast, the speed of the buses are getting so high that we're running into different bottlenecks. Even in state-of-the-art NAND SSDs, there are some serious limitations that Optane is great at fixing. Right.
So let's think about that a little bit more, because Optane offers the great write performance. That's the hallmark of the Optane drives, right? And but they've got some capacity limitations. So if we can get in the SAS form factor, 30 terabyte drives or whatever was available there, NVMe, the story is a little bit different. But the reality is most people are buying 2 and 4 terabyte SKUs anyway for these arrays, or at least that's what NetApp and Dell tell you where their sweet spot is. So are you seeing more smaller Optane drives in a multi-tier architecture, or are I guess perhaps some that really want some really heavy write performance could do a whole volume of just Optane? What sort of configurations are you seeing?
Yeah, I think when we built Optane as a technology, the core capability of it is to have DRAM-like capabilities at much, much less cost. So it's really a memory anchored development technology, and it's complementary to what we're doing with NAND. So we don't think of Optane as coming in and completely replacing our NAND SSDs in the capacity tier anytime soon. It's really about tiering, and tiering is a very broad category for us geeky engineers. I am an engineer by training, right? And I apologize, it'll probably come through in this podcast, so I'll start talking geek, so pull me out. But
that's okay, go for
it. But in the end, what you're doing is you're solving bottlenecks in the different storage stacks as you scale, right? So when you go from 10 gig Ethernet to 25 gig Ethernet, we saw a big transition from people going from SATA SSDs, which were pretty balanced to a 10 gig Ethernet infrastructure, to 25 gig Ethernet. They bought an NVMe SSDs, which, by the way, 3.2 gigabytes per second, which is the bus of a CPU, looks a lot like 25 gigabits per second on a network. It's a pretty balanced architecture. And the reason they're doing all of that, of course, is they want to buy more CPU cores, right? So, the good news for high tech and for Intel is the demand, data-centric demand, is going through the roof. Everybody wants to do things with storage. It used to be very boring. It was important. Don't ever lose it. I mean, if you lose your database, you're probably going to, lose your job and you might get fired, right? If you lose your VM, your boss is going to be mad. You have to reboot it, and it's going to take a few minutes, maybe a few seconds to get it back up. But man, you lose the storage, big time problem. So it's very critical, but It was really stored and very quickly store and forget. You would archive last quarter's data, archive your health repair records, archive some image, and then you just never looked at it again. The industry's completely pivoted now. It's all about data mining, machine learning, AI, big data analytics, Hadoop. Everything's about looking at your data as an asset and re-examining it to create new business advantage for the line of business. And so it's making the CIO now a critical part of the line of business conversation, right? They're not just talking about how to save money and keep the email going. They're talking about how they can have infrastructure that creates better insight in their customers, better products, better services, and fast as possible, because the competition's moving fast too. So there's a big thing now, is transformation, where data is the asset and data mining is the way you get the business advantage, and it's making storage a core part of how you have to think. And so things used to be like, well, just stick it on tape or stick it on hard drives or whatever. Now it's, no, stick it on SSDs, and how quickly can I get it to feed the CPU? How do I get it closer to the CPU so that I can do this amazing software and get my business advantage? And that's the way the internet's built now,
Yeah, it's interesting, because I think as we look through the technologies of, talk about SATA SSDs, there's still maybe a little spot for those for a little while longer for boot drives and for some other low performance type needs. But a SATA drive, we've capped that out, right? There's no faster version of SATA. SAS had some differentiation, but we're seeing now a pretty broad spectrum. And actually, we talk about this all the time, is that NVMe can be fast, but doesn't have to be fast. And I think that's sort of a marketing challenge that that the consumers of technology have all been told, it's NVMe, it's fast, 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 fast. But there's a lot of different products in that family. And as you point out with Optane SSDs, really high performance, low latency, really great with writes. There's a whole other class of NVMe storage, more mainstream, that you guys sell to your 4500s, 4600s, those types of
QLC,
things.
we're the
And then
leaders in
there's
QLC. We're driving that transition.
there's
You know,
QLC too,
yeah.
but it's not always fast. So when you talk to people in a business, I mean, you talk about CIOs, do they, how much do they care about the individual components versus just saying, don't worry about it, CIO, this array or this solution will be good enough for all of your needs, and let's not worry so much about IOPS or whatever the concerns were of yesterday? Because it feels like we're moving a little bit past, for the array guys anyway, the million or 2 million or billion IOPS. That doesn't seem to be the lead spec anymore. It's a little bit more architecture and intelligence and other things.
Yeah, I think I think the CIO just wants to solve their problems. You know, they're trying to constantly figure out how to create new technology advantages for the company and at the same time save money, right? And I think so they have just huge pressures on them all the time. And so what we often end up doing, and with our customers, as you know, we're a building block supplier. We're Intel Inside, you know. So when we deliver a solution like an Optane SSD or a new CPU or new networking, we really work hard to create reference architectures and benchmarks and proof points to show, that speak to the heartstrings of the enterprise customer, which is, show me, you know, I'm getting a business advantage, and show me I'm saving TCO. Right, and so almost all of our white papers say, here's your business advantage and here's your TCO savings, and that's what creates interest in that community, because it speaks to both their heartstrings. They're looking for that new business advantage, and they're looking to save money. Right? And it turns out that we've often seen this, where you can use SSDs to save money because it causes an unexpected transformation. I'll give you an example. At Twitter, you know, we were working with them on taking Hadoop, which is, you know, the big data analytics kind of open source community of default. You know, it's probably the most prevalent. There's lots of others, but they use Hadoop, and they had never used an SSD. They were just using hard drives, because Hadoop by itself is not considered to be a cacheable workload. When I do a query on Brian Beeler, that workload, you know, is going to create a Google search, and it's going to order you and everything based on priorities. But how often am I going to search for your name again? You know, you search something else. So there's perception that it wasn't cacheable. But what we found is that there's certain parts of their workload, namely this thing called yarn, where they have to generate the analytics results. So they're manipulating all this data they got to order it, prioritize it, rank it, so that when they provide it to you, the end user, you see it in a way that's very structured. And it turns out that's a very active workload, right? And so we showed them, by putting an SSD, you know, just sticking an SSD in that server, we could dramatically improve their performance. And it was really crazy how much of transformation it was. We took them from, you know, basically, you know, thousands and thousands of nodes. We divided it by 4. So the new infrastructure, they were able to consolidate 4 to 1, right? Because the SSD unleashed all these bottlenecks they just didn't know, right, in our architecture. And it didn't cache the data; it cached the metadata, it cached the information they were manipulating. And by the way, they also went from a very low core count CPU to a very powerful CPU, because now they could take advantage of that. So they were, you know, from a CPU myopia, we sold them a better CPU. They went to better Ethernet networking, because now they could feed these machines all this raw data. So it was it was not just buying a widget and sticking this widget in the place of that widget. It was transforming how they built their storage architecture. And we see that all the time. Right?
Well, that's at a big scale. Do you see the same thing in a smaller scale for your smaller channel partners and systems integrators that are doing things maybe not quite at, you know, large data center scale, but does the same argument make sense there, that it's an Intel ecosystem, and when you combine all these Intel parts together, regardless of which ones you select, as long as they're right for that job, that you'll have a better story there? Or are they more component driven? Like, how does that change as you go smaller in the customer you talk to?
Yeah, I mean, clearly the types of problems they're solving are either different or they're much reduced, right? But you know, when you look at it from an engineering point of view, the underlying problem is very similar. They're still trying to fix a bottleneck to scale, and so like one of our most popular places that people are buying Optane right now is in hyper-converged server infrastructure. This transformation in enterprises from buying, kind of best-in-class networking, best-in-class storage, best-in-class servers to buying an appliance that aggregates all of that and is all software defined. And that's a big transformation in the industry. And it turns out Optane's really amazing at that type of workload where you're running multiple VMs on a very small amount of clusters, and we just did this big thing with a baseball team, and we were, it's going to be a big deal, but they went and did this transformation when they bought servers, networking, and storage of buying these appliances, these hyper-converged appliances, and they got a huge benefit out of Optane because depending on the workload they were doing, it was very interesting. Like they were doing ticket entry, right? So you walk in the building and you have this hyper-converged thing, and it's the primary app it's running is bringing people in the ballpark. Well, guess what? That's a mission critical thing to do. You have 50,000 baseball fans that want to come to your ballpark, probably want to let them in, right? So here's this.
You used to have 50,000
fans
anyway.
It'll get back. We'll come back, right? Maybe it's 12,500 for a while, but it'll get back, right? And
there you go.
And then they had to sell beer. Right, so you and I think of beer as okay. Well, that's mission critical for them. That's their profit.
That is mission critical.
They got to sell beer
on a Cincinnati summer. That is mission critical, buddy.
Exactly. And then you run into things like they do their business analytics on this thing too. They'll do their kind of like Moneyball. You ever saw that movie with Brad Pitt?
Mm-hmm.
They'll do this baseball analytics, and so they're running a machine learning workload, a big data workload on that same infrastructure. So it's like a Swiss Army knife. And so what Optane is really great at is peaks. Like when you're using your infrastructure for something mission critical, some time-driven activity, that's when Optane really shines because NAND SSDs are really, really great at reads. They're pretty good at writes, sometimes. But man, when you use them a lot and you have lots of tenants, lots of VMs hitting them, there's this phenomenon called the noisy neighbor, which is inherent in the architecture of NAND. Sure. And it just starts falling down. And we've seen that in our benchmarking. We can show you that you can run like the VxRail. We showed it running at all SAS SSDs, state-of-the-art SAS. And then we showed it running Optane. Mm-hmm. And you can see as you start putting a lot of write pressure on it, the SAS SSDs just fell off. And it's not because they weren't well designed. It's just the nature of NAND. It's the nature of the technology. Whereas Optane was solid as a rock and held you through those peak times. So when you think about Optane, you think about business analytics, you think about active data, think about mission critical workloads, and you think about solving these peak bottlenecks. And so that's where we find it in small infrastructure too, where it even like edge, right? You're out there on the edge, I don't know, you're on an oil rig. I'm making up a case study here. You want to do some seismic and understanding of where to drill your next tunnel, right? That's real-time stuff at the edge. Optane is a great opportunity to help something like that, right? And so, really, it's a complement to NAND. We don't think of Optane as replacing NAND in high capacity. We think of it as we allow NAND to move down its evolution, which is ever lower cost, especially the move from 3 bits per cell, which us geeks call TLC, to 4 bits per cell, which us geeks call QLC, right? That movement of more density of NAND actually makes it worse over time. It's actually getting slower, but way cheaper. And Optane is a great complementer to that, right? When you combine those two together, very small amounts of Optane, by the way, we're not talking about a lot, we're talking about a few percentage points, can make a big difference in solving these bottlenecks. And that's what we find in all our case studies, and we probably have like 15 on the internet. There's many more. We've got 150 POCs underway. We have about a 75% conversion rate, ramping this thing in a lot of places. But I will say that it does take education every single time because we walk in with an Optane SSD that, is great, but it's relatively expensive compared to NAND. So we have to show them how they get that business advantage, how they get that TCO, so that they get the adoption.
Well, you bring up a lot of good points. We did some work last year with Data On. They've got Azure Stack HCI clusters that they sell. They're an Intel partner, and in that review, it wasn't even Cascade Lake yet. It was still the step before. We had a little bit of Optane in there as part of the data tiering structure, and saw the best 4-node, so mid-market HCI cluster performance out of anything that we had seen. It wasn't even close. And that's on that Microsoft platform that was fantastic. And for these software-defined platforms they've got to be smart, right? They've got to be able to take advantage of tiers of storage. And it could be like you talked about TLC and QLC, it could be a structure where we've got several different types of flash, and now we're tiering across multiple different types and capacities and performance profiles of flash. And I think that's all really interesting, as long as you have the software element on top to manage that. The other thing that you talked about a few moments ago, though, too, that was so important in that cluster is that it was 25 gig networking in the nodes. And I don't think you can understate enough overstate enough how important networking is to this whole ecosystem, that if we're going to make all these nodes faster, that the ability to move data on and off is going to be critical. And that's in current platforms. When you look ahead to what Intel's talking about publicly, at least around next gen server CPUs, things like PCIe Gen 4, and I know we're not quite there in terms of being ready to announce anything from Intel, but those technologies are going to make networking really important too, as you speed up everything else in the whole stack.
Absolutely.
What do you guys? Are you seeing wider acceptance or adoption of that notion?
Yeah, absolutely. I think in order to really deliver value going forward, you can't just benchmark your cores, right? You gotta show the solutions point of view. We're working with these hyperscale clouds, the Super 7, the biggest people in the world. And you know what? Networking is right front and center to all of their thinking. How do they build a balanced infrastructure? And we're about to go through a revolution there, because optical, we were trying to crawl as far as we could up the copper. We got it all the way up to 40 gig, but most people ended up adopting 25 gig. Because that multiple was more harmonically balanced to the CPU buses, right? So 3 gigabytes per second, Gen 3 PCIe looks a lot like 25 gig ether. Those two are sort of balanced, right? When you go to Gen 4, you're going to double that. Turns out that creates an opportunity for optical. And once you go optical, it's like a whole new world. I mean, the scaling of the network is really just limited on your transceiver now, not on the media. Copper was limiting networking before. Optical makes the transceiver the problem. It's a semiconductor problem again. And so we're going to see an enormous increase in available network bandwidth, especially in the cloud. They'll be the early adapters. But yeah, like we said with that Twitter example, they had to move to 25 gig Ethernet because they needed to speed this thing now. It could just do so much more. They needed 25 gig just to balance it out and make it work, right? And we've seen that in the cloud too. And hyperconverged is the same way. They'll build the networking layers in between them and use RDMA so that they can very quickly deliver a platform level scale. Because with storage, unfortunately, you have to create at least 3 copies. Then you right away. Then you have to sort of at least start archiving that to the capacity. There's a lot of work you go on inside the box. So when an end user writes to a storage box, they get this acknowledgement back. They go, okay, you stored my data. Well, there's a lot more going on underneath the hood with that data. They're manipulating it. They're erasure coding it. They're spreading it across multiple nodes. They're doing all this stuff for data integrity, and all of that stuff needs networking. It's super dependent on the network.
Yeah, absolutely. I've got a number of thoughts and questions about that. So when you talk about the cloud partners and what the relationships are there, obviously they're using, well, you tell me, are they using Optane as part of their offerings and the technology's largely obfuscated to the user, or are they doing some Optane specific tiers for really high performance workloads? Mm-hmm. What kinds of, I know Amazon's got like 8 billion offerings. It's hard to keep track of what they're doing. Yeah. And so, but tell me what you're seeing.
Well, we have 2 versions of the Optane technology, right? We have the DIMM, we call persistent memory, right? PMM. And then we have the SSD. And they're complementary, right? They kind of solve different problems. The DIMM is actually a better use of the media. It actually runs at DRAM speeds. It's got 200 drive writes per day. It's got great latency. It's when you're on a CPU memory bus, you have all these resources. So it's probably the best way to really unleash the underlying media. The SSD is also very helpful because we have customers who want like dual port, or they want expandability, they want hot plug. And so the 2 of them, really find different niches or whatever as they ramp. But it's typical of any new technology. What we do is we find an application that really benefits from it. So At Alibaba, for example, it was their PolarDB, their MySQL kind of database. At Amazon's using the DIM for an acceleration thing, right? And so we find is they typically take one of their offerings, they'll build a optimization for it using Optane, and then they'll release that SKU to a customer saying, hey, if you really want to have the most amazing database queries on whatever it is, we'll release it. So, and then we unlock it each time. So like at Baidu, they have this AI storage accelerator, because one of the problems with AI is it takes a while to hydrate an AI algorithm. You have to, half of, a quarter or whatever of the work, this is figuratively speaking, every benchmark will vary, but a quarter of the work of doing anything with AI is just getting the data in a format that you can run your training algorithms on it. And so you have to suck all this data in and do a bunch of reads and writes and structure it, and then you can do your algorithm, right? And so Baidu is using Optane as a way to very quickly get that structuring done so that they can then feed the AI algorithm that the customer writes, right? And so it's pretty typical that they'll pick an app that they think can benefit from it. We'll do an optimization, they'll release that app. And so it's one service at a time for a lot of things that are end user exposed. Now we do have Optane also going in a lot of these folks fixing kind of core bottlenecks in their infrastructure. So you wouldn't see it as an offering, but that's less sexy to talk about. But it's plumbing. You need to, you gotta have plumbing, right?
Yeah, very much. So so that's at the cloud scales. We look down to more mainstream enterprise use cases. We talked a little bit about what Dell's doing, a little bit about IBM. When you and I met last in Texas, you were excited about a number of software-defined players that we talked about. And I know recently Vast Data has launched version 3 of their product. I think that's one that was on your radar recently is one that you're excited about as well. What from an Intel perspective, what's going on out there in the software-defined world aside from HCI that's got you guys excited?
Yeah, it's a really good question. I think so. Database is a very active workload. So anything that's around a database is very beneficial. And I was going to look through some of our case studies here. We have so many now. Anyway, like something simple, like we're working with a company called CareStream, and they're just doing it for image processing. They store images, and it turns out that the movement and storage of those images, the rendering of those images, is a write-intensive database querying workload, and Optane looks really good at that. We're helping them orders of magnitude to make those image processing happen faster. And so, we have I don't know, you can go up on Intel.com, you can probably see 20 different case studies of different usages.
Sure.
And so so I would say machine learning, AI, big data, database analytics, for the hyper-converged infrastructure folks, it was just the tiering helps with solving their performance bottlenecks, so it gets them better overall average IOPS, better overall quality of service. So it's kind of I'd like to have a pithy one saying, well, this is the killer app, but it seems like it's a lot of apps in the world of cloud, in the world of enterprise, where we have shown value. And I expect that just to grow up over time.
Well, it used to be in the early days of Flash, a lot of the vendors, I think back to Fusion IO, who was one of the leaders at the time for edge card flash storage anyway. And there was always a dream back then that you'd give an application, whether it was a database or SAP, it doesn't really matter, or an AI application, access to the storage and let it communicate directly with the storage in ways that applications hadn't been used to because they were all hard drive based and they were sort of at the mercy of the hard drives. On the software side, what is there anything going on there well, I know there is something going on there. What's going on there to enable the more forward-thinking guys like an SAP HANA who can take advantage of either Optane as an SSD or perhaps more appropriately persistent memory? Just how do you think about software and integrations and APIs and things like that to make
it's a brilliant question, and I think it's a fundamental challenge for the industry. I'll just tell you right now, I think we're providing so much more capability now because we're going to optical, because we're going to networking, because we're going to tens of cores of CPUs. We're going to have the hardware resources that are coming online are challenging the way people did software. Like the HyperFlex folks at Cisco, they did something brilliant. We used a feature in our CPU to create a data path through the hypervisor so that they could basically talk straight bare metal to the SSD without any overhead associated with the virtualization infrastructure. Virtualization is amazing, right? It's allowed us to consolidate many servers into one. It's been a big TCO win for customers. We get to sell higher core count CPUs. We're okay with that, right?
Sure.
I think the software industry is really going to face a huge challenge because delivering storage through the kernel, as it is right now, is a bottleneck. And the kernel is a bottleneck, right? So this Cisco HyperFlex creating a path to a kernel, and actually not just the kernel, but the hypervisor avoiding that big bottleneck, right? So things like the movement to containers is great for us because it creates a bare metal-like feeling to the drive. The process has more direct access, right? And so you're seeing a lot of innovation in the software ecosystem now. There's two big ones that I can talk to. One of them is this thing called Storage Platform Development Kit, SPDK, which is creating a user space version of storage. So it's taking everything that would have been in the kernel and pulling it into user space, by the way, one service at a time. And it's creating a separate process that runs independent so that, and even uses polling. So you're not even using interrupt. You're actually the data is going to come back so fast to you that you can pull and bring it back out. In the persistent memory thing with SAP HANA is a great case study. They had the ability already in their architecture to directly place memory. It's an in-memory. They're the hallmark study for in-memory database. They already had the ability to directly place data where they wanted it and what type of media they wanted. So when we brought the persistent memory to them, it was very quick. It was a very quick adoption rate. Other customers don't have that in their software architecture. Their database doesn't understand the concept of ridiculously fast storage being next to memory, a persistent memory DIMM, an Optane DIMM. And so we built this team. We have this whole team. We built this thing called the Persistent Memory Library, DEK,
right.
DEK, that's right. I'll get this name wrong. Persistent Memory Development Kit. I'll say it right. And that was really to show the application saying, hey, maybe you should take on the ownership of this storage asset because it's so damn fast that you go through the storage stack, you're wasting a lot of time that you could just get the answer. Literally, you don't have to. Some of these apps, you don't even have to, park yourself. The old model with hard drives was, oh crap, I got to go get something on the hard drive. Okay, can you go get me this data from the hard drive? I'm just going to park myself as a process over here in the corner and give me an interrupt. Bring me back when the data shows up, right?
Right.
And from a CPU's perspective, that felt like months, right? In our seconds, that felt like a long time. Now with the Optane technology, it's literally like, I want the data. You have the data. There it is. It's there. You don't even have to wait. It's just there, right? And so it's changing software models. There's a lot of software innovation. I think VAST, from a storage point of view, is really one of the cool case studies because they've done their claim to fame is they're delivering a storage class system that's quote universal. They can do every workload, and it's almost hard drive prices. It's of that class, and the way they get that is they adopt QLC NAND. So they're one of our early adopters of the 4 bits per cell NAND, which, by the way, took some software effort for them to adopt because 4 bits per cell NAND does not behave exactly like 3 bits per cell. There are some corner cases you have to work through. But then they used Optane in front of it as a buffer, and they're doing really cool stuff with it. They're not just using it as a traditional, okay, I'm going to store everything in a buffer. They're actually SSD aware. They know exactly how big the QLC drive stripes are. They don't write to it in suboptimal ways. They lay out the data very well, so they get great endurance. And they use Optane as their working set, so they could do things like inline deduplication, inline compression. And that gives them that business advantage to transform their customers. So they can say, hey, I know it's all flash, and I know it even uses Optane, which is relatively expensive. But when we use it in this methodology with compression and dedupe, we can almost get you something that's hard drive prices, which is stunning, right? It's another transformation. So I think, VAST is a great leading indicator of how the way tiering is going to change going forward is it's going to be super cheap capacity NAND, QLC, and even 5 bits per cell someday, coupled with this Optane to fix all the sins, because everything NAND's not good at, Optane's really amazing at, right?
Yeah, you talked a little bit about penta level cell. You hinted at it there, and I know Intel's talked about it a little bit, and that's the future for capacity for flash. And I think that's one of the things, because we all commonly accept that flash is more expensive than hard drives, but hard drives have really, despite HAMR, despite shingled magnetic recording, despite some of these other technologies, helium drives, they're really going to run into the problem where there's only so many tricks you can throw at it before it's too expensive to continue that development path, maybe. But when you take something like a QLC drive, even if it needs to be protected a little bit by something faster in front of it, whether it's RAM based or Optane or some other media, that so be it. When you take a look at, I go back to Dell where we started with PowerStore, they're guaranteeing for most workloads a 4-to-1 dedupe and compression rate. So if they're going to guarantee 4-to-1, now your 2 terabyte SSD is more like an 8 terabyte SSD. And the gap starts to close pretty quickly. The smarter you are with data placement, with data management, between even QLC drives and hard drives, that price delta keeps compressing. When you look down the road with 5-bit NAND, it's got to get better and better, right? I mean, I know we're sort of speculating at this point, but you've got to think the cost metrics keep getting better.
Yeah, I mean, the simple math, of course, is you divide the bits, and it's more complicated than that. But it's not that easy. But 4 bits versus 3 bits is 20-ish% cheaper, right? 5 bits versus 4 bits is versus 3 bits is 40-ish, 40-ish% cheaper, right? That's a mathematical statement, not a price quote.
Sure.
And and hard drives are having a problem. It's weird because the problem that we're seeing isn't necessarily the fact that they can't grow their capacity. It's the IOPS per terabyte. It's really an interesting phenomenon because, great, I have a 12 terabyte hard drive, I have a 24 terabyte hard drive, but it's still moving at the same 7,200 RPM. And so the bits are getting bigger, but the speed's getting worse. Everything's getting worse. Hard drives are getting worse on performance, exponentially worse, right? Because they double their capacity, it's the same speed, everything gets cut in half, right? And it's been going on for quite a while. And it was one of the initial reasons why we started seeing, even back in 2008, 9, 10, the first SSD we sold was more than 10 times as expensive on a dollar per gigabyte. It was SATA, just more than 10 times expensive and our SSDs today are still way more expensive than a hard drive. But people are using them in place of hard drives all the time because it solves these critical bottlenecks. But they do it when they get that transformation where they go, oh, if I use the SSD, I can buy, I don't know, 2 nodes less, 25% less nodes, or half the nodes. Or the Twitter example was sort of an all-star. 1/4 the number of nodes. That's not to be expected every time. That's a huge win. And the math pencils off very quickly. Yeah, I'll buy a very expensive SSD. I'll buy a very expensive CPU. I'll buy 25 gig Ethernet. If I can buy 1/4 the nodes, yeah, I'll do it. And so that type of transformation is part of the exercise. But I do want to make sure that I make one point really clear, which is I saw a lot of very small size Optane SSDs. Our maximum size is 1.5 terabyte. That is not my highest selling SKU. People are very smart about how they do this tiering, and they're tiering only the data they need, and they're doing it very smartly. And so I'm not too concerned about our capacity growth. We are growing over time, but it's really about that complementary, QLC to Optane, PLC to Optane,
Well, you guys sell a little baby 100 gig version too in a U.2 form factor, don't you?
Yeah, we have it. Actually, we have it on a gum stick, the little M.2 also.
Oh, the M.2. So is there decent interest for those little tiny ones?
Yeah. So there are some workloads that are just like journals, like they're just journaling something, snapshotting a write because Optanes are really amazing at write. So they journal the write into Optane just to temporarily store the data. And then they very quickly evacuate that. Or sometimes it's even, we have one customer that they do the writes to Optane in case of power loss, but they never read unless they actually have a power loss, right? So it's forever a write buffer. And that's a very small size. And so we do things with caching too. Sometimes caching can be very small. I'd say typically we're seeing 375, 750 in the hyperconverged is where we see a lot of that. In the dual port, those folks will buy bigger drives because they have bigger arrays. We're doing okay on our ratios, right?
Yeah, I mean, even the little ones, though, we just reviewed Lenovo's got an SE350 Edge server. It's full enterprise server, but it's 1U. It's a half width. You could throw it in a backpack if you wanted to, and they can support 8 drives for data in there for a little like POS retail sort of use case where you might want some performance in there.
The sexy word is edge. It's an edge use case. That's the new. That's the
yeah,
new.
Yeah. Ask 12 people what it means, though, and be prepared for a dozen.
Well, I want to know what you think it
definitions.
means. I don't care what anybody else thinks.
Well, it's taken over for what we used to call robo. I think, in addition to manufacturing and 5G poles and all sorts of other things. But pretty cool use cases where you could take a little bit, a little bit of Optane and still accelerate those workloads. Even analytics that are being done at the edge now, which is a really neat emerging use case, I think, rather than shipping all the data back to the data center for processing, which you may not even want to store long term if it's some sort of real-time information that's not super actionable later from an analytics standpoint.
Yeah, the fundamental theory for edge, the thing that really causes edge to happen, as crazy as it sounds, is the speed of light. If it sounds crazy for us to talk like this, but literally you can't run things in real time, remote, like a car, automotive, you're never going to connect that to the cloud, right? It's got to be real time. And so the speed of light actually is creating a fundamental problem for all of our industry relative to edge, which is you can't centralize all that data if you need it real time. If you need it batch and it can be done over 24 hours, fine, move it wherever you want. But if you need to make decisions in real time, or you need feedback, it's mission critical. Speed of light's a problem. Strange. I know who would have thought we would be talking about the speed of light being a problem, right?
Well, definitely, if you're sitting in a self-driving Tesla, you'd prefer it do some of those computations on site rather than waiting for cloud latency to return the decision about when to turn or when to avoid a dog that ran into the street.
And that's obviously one of the most mentally interesting ones.
Yeah,
but
easy to
even
understand,
boring
right?
things like, hey, the cash registers have to run. Speed of light can be a limit.
They do. Have you ever been in a coffee shop, a Starbucks or something, when their POS system is down? It's not a fun place to be.
So there's super sexy ones like Tesla. There's really boring ones at the edge too, and they all have the same issues. Speed of light is a problem.
Right. Absolutely. I know we're at the end of our time, but before I let you go, what can you tell us about what you're thinking about in terms of the future of Optane SSD? What are you guys looking at? What are you thinking about in terms of what comes next?
Yeah. Well, I think we're very early. We've been working on this technology for a long time. We got our first production SSD a couple of years ago. The first DIMM actually was last year. Really, it seems like it's been forever, but it really started shipping last year. And so we're all working on our next generation versions, and we've learned a lot of lessons from the first one. The first SSDs are really amazing. The second ones are scary good, and I'm teasing you because I'm not going to tell you how good they are right now. But the roadmap is going to be extremely compelling. As you look at it over time, exponentially, we're going to increase our performance, whereas our NAND SSDs on working data, on certain things, are just going to look amazing. 100% reads, and all you want to do is read an NAND SSD. It's going to always look good. But if you want to do a lot of active data on it, as we move to more bits per cell, the NAND SSDs are going to get worse. Optane's actually going to get better. So every time we go over our roadmap, you're going to see this separation where Optane is going to become more valuable as a bottleneck remover, mostly because everything's getting slower and Optane isn't, right? So.
Well, that's cool. We look forward to it. Thanks for your time today. We appreciate you joining the podcast, and look forward to seeing you in person next time, hopefully. So maybe this fall if we're lucky.
Well, take care, everybody.
All right. Well,
stay safe.
Thank
Keep
you.
your family safe. We care about people, man. So we'll get this COVID thing figured out, but please
I know.
please
We
take
will.
heart, and we all
All right.
right?
Looking forward to it. Thanks again, David.
Bye.
I'd like to thank David again for joining us on the podcast. We've got all sorts of other great things going on, a number of other projects. Be sure to check out our subreddit. We just gave away a server that will make its way into a new home lab. So /r/StorageReview, we give away almost everything we can. So we've got a lot of good things going on there. Hit us on Instagram @StorageReview if you want to see some pictures of projects we're working on. We're on Twitter, we're everywhere. So hit us up on the socials. And if you want to reach out, we're happy to engage. info@storagereview.com. Thanks for tuning in. Bye-bye.